Now, let's talk about combinations of R objects chosen from n different objects. By definition, a combination is any selection of a set of objects irrespective of their order of arrangement. In other words, any subset of R objects or elements of a given set of n objects where R is less than n is called a combination. So again, we are going to choose or select any R objects from n without order. So compared to permutations, so for combinations, order does not matter. So for instance, combinations of 4 taken 2 at a time. So for a set S containing A, B, C, and D. So we are going to pick any 2 elements. So order does not matter. So in other words, again, it's going to be any 2 element subsets of the set S. So it could be AB, A, C, B, C, and so on. So notice we're going to use the curly brackets. That means we're using the set language. So, and notice that B and A pair and A and B set, they're going to be the same. So we're not gonna to list them twice. So again, the order of elements does not matter. Now let's talk about computing formula for combinations. So n choose R, so the way we pronounce n choose R, so letter C stands for choose, could be found by the following formula: n factorial over r factorial times n minus r factorial. So again, n choose R, it's the total number of combinations of n different objects when R objects are taken at a time. So R is less than n. So n the total number and R number of ways taken the objects. There are some properties. The first one, n choose 0 is 1, so no matter what is n. Second one, n choose n equals also 1. Let us see, n choose r, it's the same thing as n choose n minus r, and there is a connection, a link between permutations and combinations that could be given by the following formula: r factorial times n choose r equals n pr. Now, let's talk about permutations versus combinations. So again, for permutations, order does matter. It's ordered list. So we could think of this as a list. 1, 2, 3, so on. For combinations, it's an ordered group of sets. So we will just put everything in a basket. Find the value of each of the following. So let's use the formula n choose r. Now, say we have 6 choose 2. So your n is 6 and your r is 2. So by the given formula, it's going to be 6 factorial over 2 factorial, 6 minus 2 factorial. Let's simplify this. All we need to do is just write it explicitly. So it's going to be on top 6 times 5, keep going all the way down until you hit 1. Now let's simplify bottom. 2 factorial stands for 2 times 1. 6 minus 2 is going to be 4 factorial, and we're going to apply the definition. So keep multiplying 4 all the way down until you hit 1. Now, there are common factors from top and bottom that can be cancelled out. So from 4 all the way till down 1. Same on top and bottom, so it goes away. We can reduce our number by this. And also, 2 goes into 6 3 times. So it's going to be just 3 times 5, which is 15. That's the answer. So answer key for the rest. You can work it out and check. Now, how to get combinations from permutations? So since for combinations order does not matter, we could simply consider AB, for instance, and BA being a same element, a same pair. So we can kind of squeeze that elements where order changed. So ABBA is going to be the same pair. Same for ACCA, it's going to be the same. And finally, for BCCB, it's going to be the same pair for combination. So by using this given connection formula, so 6 divided by 2 is going to be 3. So 6 is the number of permutations, 3 is number of combinations. So if we divide the number of permutations by the number of n factorial, which is 2 in this case, it gives you the number of combinations, which is 3. There are some problems to carry out. More. Review. Find the value of each of the following. Solve the equation. There are some more problems to carry out. More problems for review. More problems for review. More problems. All right.